Hola, pre-calc. We've been talking a lot recently about derivative and the definition of derivative, and now it's time to talk about some of those shortcuts and the derivative rules. We've already talked about some of them. First one being the constant function. And for example, that's like y equals 2, y equals -8, and so on. So when you have a constant function, we say that if f of x equals some constant c, then the derivative of f with respect to x, which could also be written the derivative of c with respect to x, is 0, because the slope of our constant function is 0. It's just a horizontal line. We also discussed a linear function. And if you have a linear function that is in the form of f of x equals mx plus b, then the derivative of f with respect to x could also be written as the derivative of the function mx plus b with respect to x. And we know that that is just f. And those two are easy enough, but let's get into some other shortcut rules. That'll be new for most of you, although I know some of you already know them, and that's this one, which is first called the power rule. This is the rule that everyone seems to get from their friends or whatever, telling them, why are you doing the long limit process? Just do this. Well, you got to learn the long way before you can learn the short way. So the derivative rule says for any positive integer n, the derivative of x to the power of n with respect to x is n times x to the n minus 1. So let's knock out some examples. First example, 1. Find the derivative that probably should say example instead of 1, so I'm going to fix that because it's going to drive me nuts. It might not bother you, but it's going to bother me. So, all right, take the derivative of x to the 6th with respect to x. All right, what do? The exponent comes down, multiplies with the leading coefficient. In this case, it's 1. So 6 times 1 gives us 6. And now we have x to the n minus 1. And 6 minus 1 gives us 5. So far, so good? Awesome. Go again. Let's do x to the -3 with respect to x. Okay, so again, exponent comes down, and then you subtract 1. Hi, careful, we're dealing with negatives here. -3 minus 1 is -4. And then you may think to yourself, okay, I can leave it like that, or you can rewrite it so you're dealing with positive exponents, and that exponent goes to the bottom. Both of these answers represent the same thing, and both are equally fine. And you're probably thinking, but what about if on a quiz or a test, well, I don't know which one to use? Read the directions. If it says positive exponents, then give me positive exponents. All right, number 3. Take the derivative of x with respect to x. Okay, yes, we're in the power rule section. So you could think to yourself, okay, what's the exponent on that x? 1. Well, that 1 comes down, you subtract 1. Oh, that's 0. X to the 0 is just 1. It's just 1. The other way you could think about it is, hello, hi, x linear function, coefficient, slope, 1. All right, 4. Let's get into f of x equals 8x to the 3rd plus 5x plus 1. Okay, our example directions were find the derivative, so f prime of x equals power rule. Bring down the 3, it multiplies with that coefficient. 3 times 8 is what? 24. x to the subtract 1 that is squared. Okay, you could think to do the power rule again, or 5x is linear. What's the slope? 5. And what's the derivative of our constant? 1, 0. So f prime is just 24x squared plus 5. All right, number 5. F of x equals x cubed plus x to the negative 1 plus 1 over root x. 1 over root x is not written in an exponent form or an x to a power. Perhaps we should rewrite it to make it a little bit easier for us. So x to the third plus x to the negative 1 plus, okay, x to the square root, the square root of x is x to what power? 1/2. Very good. Okay, but wait a minute. It's 1 over, so there has to be a negative sign in front. All right, there we go. Now let's take the derivative, f prime of x. All right, x cubed gives us 3x squared. Bring down the negative 1, subtract 1. Bring down the negative 1/2, subtract 1, that becomes negative 3/2. Okay, you could leave your answer like this, or you could rewrite it so we have positive exponents, and you say 3x squared minus 1 over x squared minus 1 over 2x to the positive 3/2. Again, these two answers represent the exact same thing. It's just a matter of what directions are given and what notation you have to put it in. Okay, so with that being said, let's do another problem for rewriting, and then I will give you 2 you-dos. All right, y equals x cubed minus 3x squared plus 4 all divided by x. Wait, Miss Gutierrez, what do I do? Well, guys, let's actually perform the division. Okay, so when we rewrite this, we get that y equals, x cubed divided by x is x squared, minus that becomes 3x, and then that becomes 4x to the negative 1, because 4 over x can be written as 4x to the negative 1. Now let's take the derivative. Remember, we can write that as y prime or dy dx. 2x minus what? 3. Good. And then what happens here? It becomes negative 4x to the negative 2. And we can say, if we wanted to rewrite this, 2x minus 3 minus 4 over x squared. Okay, awesome. So let's give you some you-dos with the power rule before we move on to our next rules. Okay, you do. What number are we on? I think we just did 6. So we'll make this 7. And if I'm off on a number, you will deal. All right, 7x to the 5th minus 4x squared plus 8x minus 9. And 8, we will say f of x equals the quantity of 3x minus 7 squared. Okay, so go ahead, pause the video, take some time to rewrite if necessary, and take the derivative, and then come back and we will go over these together. All right, so welcome back. Let's talk about this. In number 7, we have dy dx equals, hopefully you got 35x to the 4th minus 8x plus 8. Number 8 required a little bit more work. You have to expand this out. Expand meaning foil it. And you would have gotten 9x squared minus 42x plus 21. Now that it's rewritten, we can take the derivative and say f prime of x equals, and hopefully your answer was 18x minus 42. Okay, so if you have any questions on the power rule, make sure to jot them down, bring them to class. We will be talking about it. But what I want to get into right now is another way to look at number 8. And that is when two items are multiplied together, we have another rule that we're able to use, and that rule is called the product rule. And when you tackle the product rule, we say for f of x and g of x. And we have to note that these are two differentiable functions. Now, when I say differentiable, I mean we are able to take the derivative for f of x and g of x. The derivative of f times g with respect to f equals f of x times g prime of x plus g of x times f prime of x. And you will hear me say front d back plus back d front. And that's kind of the little, like, I'll say shortcut memorization for the product rule, because it's the first times the derivative of the second plus the second times the derivative of the first. And that's when I say front d back plus back d front. So when we look at number 8 again, you're going to see, okay, so if I were to do f of x, which was 3x minus 7 squared, or I'm going to write that as times 3x minus 7, we can take the derivative using our product rule by saying front d back, and the derivative of the back is 3, plus back d front. And you could leave it like that, or if we wanted to distribute, you get 9x minus 21 plus 9x minus 21, or 18x minus 42. And you might be thinking, but wait, Ms. Gutierrez, that doesn't necessarily seem that much shorter. Well, that's when you get to decide, is it easier just to FOIL something out, or do I want to do the product rule? Well, what happens is, when we have with the product rule, I will now start formal example number 1. Sometimes you have to use the product rule, or it's a little bit faster to use the product rule. For instance, if I say f of x equals x to the 4th minus 2x times x cubed minus 3x squared plus 6. You most certainly could multiply a binomial times a trinomial. I think that just takes a little bit longer. So when we find the derivative here and say f prime of x, you say front. Why is my stylus not cooperating? There we go. Front d back. Well, the derivative of the back is 3x squared minus 6x plus back, and I am going to run out of room d front, which I will just write down here. Goodness gracious. I don't know if you guys are seeing this stylus issue that I'm having or not. But here we go. Okay, front d back plus back and d front. 4x to the 3rd minus 2. Don't expand it out. Don't. You can. And if you want to, you're going to get a crazy long answer, but don't. There is 100% no need to simplify. So, here we go. We did that example. I'm going to give you a you-do for number 2 and say f of x equals x squared minus 7x plus 4 times x cubed plus 5x squared minus 8. Okay, pause it. You do this one, come back, and then we'll check our answer. And we should be back. And so I'm going to say f prime equals front x squared minus 7x plus 4. D back, the derivative of the back, 3x squared plus 10x. Plus, I'm going to jump down here because I'm not going to have enough room. Back, x cubed plus 5x squared minus 8. D front times the derivative of the front, which is 2x minus 7. Don't multiply it out. Do not simplify. You don't have to simplify this, okay? All right, and ladies and gentlemen, that right there is the product rule. We have one last rule that I want to talk to you about, and that is the quotient rule. So let's title this our last section right here, the quotient rule. And the quotient rule says, let Q of x equal f of x divided by g of x. Okay, again, both f and g are two differentiable functions. Okay, so we're going to kind of prove the quotient rule here. If I were to solve for f of x, I'm going to say, oh, well, that gives me g times q equals f. I'm going to drop the x's for just a little bit. And you could say, hey, I can solve for f prime using the product rule that we just did and say that's front d back plus back d front. And that is f prime. Okay, now I'm going to solve for q prime right here. This is kind of what we were looking for from the beginning. And so when I solve for that guy, I'm going to say, okay, I get gq prime by saying f prime minus qg prime, or q prime equaling f prime minus, okay, I'm not going to write q because q is really f divided by g times g prime all divided by g. Oh no, that's a complex fraction. How do I get rid of a complex fraction? Well, I can multiply both the top and bottom by that common denominator, which is g, and I get my final answer of q prime equaling f prime times g minus f times g prime all over g squared. Okay, so that's g times g. So what I like to say and what I like to think of is in terms of f of x divided by g of x. Okay, and you're going to hear me say low d high and high d low and stuff like that. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared, or you can say g of x times g of x. Now, in terms of my little sing-song that we did with the product rule, front d back plus back d front, in terms for the quotient rule, I'll use high and low. See, top and bottom, high and low. And scoot here as you drop the W. Yes, I know. Makes it easier. They're both two letters. Roll with it. So we say low D high, because technically the high should probably be H-I-G-H, and the bottom should be L-O-W, but that's okay. Minus high D low all over low, low. Okay? So we're going to do a couple of examples here, and then we will be done. 1. F of x equals 3x minus 2 over 2x minus 5. Let's find f prime of x. Well, low d high. Well, the derivative of the top is 3 minus high d low all over low low. Don't simplify it. Don't. I mean, yeah, this one's easy enough. You totally can distribute the 3 and whatever. And if you go to do that, you're going to get negative 11 because the 6x and the 6x are going to cancel out over 2x minus 5 quantity squared. Okay? You don't have to do that. You do not in any way, shape, or form have to simplify. Okay? So let's do one more example here. And I'm going to say f of x equals x cubed minus 2x over 3x minus, let's make that a plus 6. And let's take a look here. F prime. You know what? Wait, pause this. You do it, and then come back and check your answer. I feel like the first example was good enough, and you should be good to go. And this will be our last one. All right. Welcome back, and here we go. Low d high minus high d low all over low low. There you go. There's your derivative. Don't worry about simplifying it. Unless the directions say simplify, you don't have to. What I will say, and where mistakes are made with both the product and the quotient rule, is not using parentheses to separate your work, because that brings up some confusion. Okay, so we're going to be practicing the power rule, quotient rule, product rule, all after your quiz next class. So have a great weekend, and I will see you on Monday/Tuesday 4B. Bye, guys.